Hello, my name is Lex, and I'll be showing you how I got my results for the first project. I started by making just a rectangle in Fluent. All three scenarios I used the exact same rectangle mesh setup. And the size of that rectangle, I use millimeters, and for the length of the rectangle I used 500, and for the height I used 10. So, box lights. Try that again. Okay, apply, generate. Alrighty. Close that. Okay, and then for my mesh, I set it up like this. Whoops. And for my vertical number of divisions, I use 150. Or my horizontal number of divisions, I used 150. And then for my vertical number of divisions, I used 500. And then to make the mesh look nice, I used face meshing, just like in the first tutorial. And this is how my mesh looked. Okay. Oops. And also in the mesh is when I set up my boundaries. Put on edge select, and I labeled them all just like they were labeled in the first tutorial. Now we have our 4 walls all named. Take the mesh. In the setup I used all precision as instructed. And then I left all of these the same. And the first thing I did was go to viscous model and select laminar flow. And then I went to materials, fluid, air. And for all three scenarios, I used the density as 1 and the viscosity as 0.0001, just like in the first tutorial, so I could keep my Reynolds number around 1,000 for all three of them. And then for the first scenario, all I had to do was change the inlet value velocity. I changed it to 10. Then for the second scenario, I changed the inlet velocity back to 0, and the top wall velocity I put the wall velocity as 0.01 meters a second, because when I was entering in higher numbers, when I was entering in higher numbers, it was giving me a very odd looking velocity profile, so I lowered it and it seemed a whole lot more reasonable than the other values I was getting. And then for the very last scenario, I kept the speed I increased the speed to 1 meter a second on the wall motion and changed the outlet speed, or the inlet speed to 1 meters a second as well. And then to show you how I got my charts, I'll just do the first scenario again and change the velocity to 10 meters a second. And the wall was stationary. Okay. Then I initialized. Sorry, I forgot to re-enter my number of iterations. When I ran all three of them, I used 500 iterations for all, like I saw used in the tutorial, but none of them went through all 500 iterations. I believe the most I got back was around 50. And it was on the first one as well. Alrighty. And then when I went into results, this is how I got both of the charts for all three cases that I will show you in my written explanation. And to begin with, I clicked on this right here and named it for V for velocity, and I wanted it to be all throughout. The variable is velocity, number of contours I put to 100, And then to change the legend, clicked on this, changed it to horizontal, turn the precision down to 1 just like in the tutorial, and to fixed as in the tutorial as well. And this is how I showed the velocity profile. Excuse me. Or, excuse me, not the velocity profile, the velocity contour. And then to show the velocity profiles, I unclicked that and then made 2 lines for the middle and the end, because I needed to show the velocity profiles in the middle and the end of the flow. So you have to insert 2 lines. This one, and call it mid. And for its location, and 100 samples, so it gives us a nice line on our graph, because if you put any lower it looks kind of gross. Alright, and then there's our line in the middle, and I'll just do it again one more time real quick and put it at the end. Now we have our 2 lines. Now to make the velocity profiles, you want to change the x-axis to velocity u, y-axis to y. Oops. Data series, name it for mid. I want to use mid, and apply. And this gives you a velocity profile in the middle. And then to get the one at the end, you have to add another data series, and apply. And these are how I got my velocity profiles for all 3 scenarios, and how I got the velocity contours for all 3 scenarios. And that's going to conclude this video. Thank you.